These are the lesson 4.4 notes on graphing linear equations in slope-intercept form. This is one of the most important sections in this chapter, and it's where things start to get kind of interesting. The idea of intercepts is that the x-intercept of a line is the x-coordinate of the point where the line crosses the x-axis. If you think about what it means to intercept, it means to kind of catch it, right? So this is the point where the line catches the x-axis. It occurs when y is equal to 0. That's kind of a nice reference point. The y-intercept is the one that we focus on more. That is the y-coordinate of the point where the line crosses the y-axis. It's where it catches the y. And it occurs when x is equal to 0. You can memorize that, or you can figure it out each time. It makes sense that it's going to cross the y if x is 0. And it makes sense that it crosses the x when y is 0. All right? Super, super important point here. Slope-intercept form of a line, a linear equation written in the form y equals mx plus b is in slope-intercept form. It's called that because the slope of the line is m and the y-intercept is at b. Okay, there are other forms that the equation of a line can be in, but this is the one that you need to memorize. If you memorize this one, it's a good anchor point. You can always get where you're going from here, all right? Algebraically, it looks like this. That's the slope, m. B is where it crosses the y-axis, right? So from that information, you no longer have to graph. Sometimes it's nice to sketch a graph. Lots of times it's nice to sketch a graph because then it helps you to get oriented and to figure out where you are. But you don't have to sketch a graph anymore. If you have it in slope-intercept form, then you can find the slope and the y-intercept right from the equation. So let's see, in this one, the slope is equal to -4. And the y-intercept equals -2. Okay, don't forget the sign. All right. Also notice that the y-intercept is one number, right? It's not 0, -2. It's just -2. So it's not a point, it's a number. All right. And then this one, the slope. See, it's a little bit tricky. We have to turn it around. You don't have the y by itself. That's why I made you do that section in chapter 1 where you had to solve for y. So let's come over here. All right, so we want y by itself. In order to get y by itself, I need to add 5 to both sides. You can do the little +5 here. You guys are probably getting good enough now that you can just write it over here. All right, it makes sense to go ahead and keep it into slope-intercept form. Don't put the 5 on this side because this is the preferred way of looking at it. So now you can see that the slope is 3/2, and the y-intercept equals +5. All right. If you don't change the equation, if you don't solve for y, you might think that the y-intercept is -5. But when you move it to the other side of the equation, it becomes positive. Okay, you have 2 to practice on your own. Okay, we're going to take it a little bit more. Now we're going to graph in slope-intercept form, where we're going to graph it from the equation. So the first thing we have to do is to find the slope and the y-intercept. The other thing we're going to do is to identify the x-intercept, or the point where it crosses the x-axis. All right, so the slope is -3, and the y-intercept is +3. Okay, and then I can see that my slope is negative and the intercept is at 3. So I want to give myself some room to graph. So I think I'll put this here. So the first thing you do is to plot the y-intercept, 1, 2, 3. And then you can use the slope to find additional points. Right? So remember that the slope is equal to the change in the y over the change in the x. That is the rise over the run, or you can think up over. Right? So then start at that y-intercept. And in our case, the slope is -3 over 1. And so it's going to go down 3, 1, 2, 3, and over 1. 1, 2, 3 down, and over 1. Isn't that handy? So just remember that your slope is the rise or the up or down. Maybe I should put it can be the up or down over the run, positive or negative. And then if we wanted to go back this way, you could go up 3, 1, 2, 3, and -1, and that would put you a point this way. So this negative sign could flip down to the bottom if you want to graph in the other direction. Okay. You can see that would be up 3 and back 1. Okay. Here, I hope I did that right. Oh, it's this point. We're looking for the x-intercept. So on this first example, it's easy to see the x-intercept. It is at 1. It's right there. X is 1 when y is 0, right? In the second example, we'll need to solve it algebraically. All right, so let's start the same way. The slope is equal to 6, which means that I'm going to go up 6 and over 1, okay, because they're both positive. Again, that's why I make you write it as a fraction, not as a decimal, because we want to graph up 6 over 1, up 6 over 1. All right, and that would be hard to do if it was a decimal. And then the y-intercept is equal to -7. Again, don't lose your sign. Let's see. So this time I know that I want to be at -7. So I'm going to start negative and my slope is positive. Let's see. So if I put it down here, 1, 2, 3, 4, 5, 6. I think that'll be right. A little bit of guess and check when you're graphing. Sometimes our graphs end up in funny places. All right, so we're going to plot the y-intercept first. That's the starting point. When you are graphing, you always need to put the y-intercept on your graph. That's an essential point. So let's go 1, 2, 3, 4, 5, 6, 7. And then I'm going to go up 1 over 1, or sorry, up 6 over 1. 1, 2, 3, 4, 5, 6, and over 1. 1, 2, 3, 4. Now, you know what? I'm just going to draw that line because it's going to go into, and you'll be able to see what's happening. All right. So here is the x-intercept, right? I'll draw a circle around that. What point is that? Oh, it's hard to tell because it's not on a lattice point, right? So there are some problems in your homework that are like this. So if the x-intercept is not at a lattice point, then you have to solve for x. Fortunately, you know how to use algebra. So we know that at this point, the y is 0, right? This is over x up 0. So let's go ahead and take our equation. Y equals 6x minus 7. The y is 0. Right? I'm going to add 7 to both sides. And then I'm going to divide both sides by 6. So x is 7 over 6, or 1 and 1/6. And I can see that that's about right, even with my inexact graph. There's over 1 and about a sixth, right? Nice. All right, so you have 2 problems, and hopefully at least one of those you're going to have to solve for the x-intercept. Okay, and then we have one real-life example. These are the ones that are interesting. I like those. The cost y in dollars of taking a taxi x miles is y equals 2.5x plus 2. I wonder why, after Miss Who just told you that you should always have your slope as a fraction, that now we have a decimal. It's going to get back to this word interpret. All right. So the first thing we're going to do is to graph the equation, and then we are going to interpret the y-intercept and the slope. That means we're going to tell what they mean, because that's the whole point. The graph by itself doesn't solve anything if you don't know what the parts mean. Okay. So the first thing we need to put on is the cost on the y-axis. So maybe I'll label it this way. Right. It will tell you, and that's in dollars. And then on the x-axis is the miles. Remember that a slope is a rate. Right? It's the rate. It's the y over the x. It's the cost per mile. Oh, that's what slope means. It's a rate that tells you the cost per mile. All right, then let's go ahead and graph that. Our slope is 2.5, and our intercept is 2. And this is all positive, so I should be able to keep it in the first quadrant. That kind of makes sense. You can't really go negative miles. I guess you could have negative money, but a taxi ride doesn't work like that. So let's start at 2. And then I can either graph up 2.5 over 1, up 2.5 and another 1. Actually, let's go ahead and do it that way, because I really like, if I can, to put 3 points on the graph just to make sure that I haven't made a mistake. Graphing from 2 is a little risky. So let's go up 2, 1, 2.5, and over 1. And then there's a half, 2, and over 1. And this point should be at 7, right? 2, 3, 4, 5, 6, 7. Okay. All right. And then we come to, so there's the graph, and then we come to the point where it says interpret the y-intercept and the slope. Interpret means tell the meaning. That's different from tell me what it is. Here is tell me what it is. Yes, the slope is 2.5, but what does it mean? Here the y-intercept is 2, but what does that mean? Well, the slope is $2.50 per mile. Does that make sense? It's the cost per mile. It's 2.5 per mile, but we don't write money as 2.5. 2.5 monies doesn't make sense. It's $2.50 per mile. And then the y-intercept is the starting point, right? It's the charge for getting in the taxi. It's the initial fee. And it is $2. Right? This would be like if you had a gym membership. There may even be a problem like that in the book where you have a gym membership and you have to pay an annual fee plus an amount per month. There are lots of things like that where there are startup costs plus an additional amount for every month. Sometimes it's you start with any kind of amount and then it goes up from there. Okay, or down from there. The slopes can be negative too. All right, you have another example, which is very similar. Be sure that you do not leave out the interpret step because, in my opinion, that's the most important part.